Last class I have covered stability analysis. In stability analysis, major part of the stability is the lateral stability analysis. There are two cases, one is your light well, other is your heavy well. In light well, Terjagi has given one approximate analysis. Free rigid bulkhead analysis has been taken out for the analysis of well foundation of light well. Then the derivation has been made it and we got it total D1. Once you know the D1 value, other parameter we can get it. Then heavy well, in the heavy well the assumption is not like light well, the rotation will be at the base and heavy well will rotate about the base and factor of safety is equal to 2. Then second part is your effect of surcharge. Effect of surcharge is your, how come effect of surcharge will come? Sometimes what happen, unscoured soil above the bed sea level, there are certain soil it is not scoured, unscoured soil above the bed sea level it accumulated. Because of that it acts as a surcharge. So earth pressure due to surcharge has been considered. Z is equal to equivalent surcharge height, Q maximum we got it, total resisting force we got it, allowable horizontal force will be Q maximum by factor of safety. In this case factor of safety has been considered as 2. Then next part of the design part is your maximum pressure at the base. So F maximum and F minimum we have derived. So F maximum should less than your allowable bearing pressure of the soil. The next covered is your maximum movement in the staining. What is your maximum movement in the staining? Because that will be required for your design of your particularly giving reinforcement, that has been carried out. Now we will solve one problem. Example 1. A circular well of 8 meter external diameter and 6 meter internal diameter is embedded to a depth of 18 meter below the maximum scour level. Meter below the maximum scour level. In a sandy soil deposit. The well is subjected to a horizontal force of 1000 kilonewton. The well is subjected to a horizontal force of 1000 kilonewton acting at a height of 10 meter above the scour level. Determine the allowable total equivalent resisting force determine the allowable total equivalent resisting force due to earth pressure assuming the tilt is about a point above the base, tilt is about a point above base, tilt is at the base. What are the properties has been given for this case? Gamma saturated is equal to 20 kilonewton per meter cube, phi is equal to 30 degree, factor of safety is equal to 2.0. What has been given? A circular well of 8 meter external diameter and 6 meter internal diameter is embedded to a depth of 18 meter below the maximum scour level in a sandy soil deposit. External and outer diameter is given. The well is subjected to a horizontal force, lateral force is given. So, the tilt is about a point above the base. What does it mean? For first one, it is a case of light well. For second one, it is a case of heavy well. It is a case of heavy well. Let me draw it. What is given it? First one, it is given it is your outer diameter is your 8 meter, inner diameter is your 6 meter, and above this is your 10 meter and this is your 18 meter, this part, and this is your D, this is your H is given. Then what does it mean? The first one case is given as per the earlier. This is your light well, this is a Q. This act at a distance point of rotation at a distance point O, and this will be acted upon by this and this will be your D1, and tilt is about a point above the base. That means this is about a point above the base. If this is my base at point O, hence it is light well. Then second part is tilt is about the base. I am drawing the earth pressure distribution diagram. This will be a Q. Then this will be your about the base. that means this is your heavy well about the base. These are the things given. What are the things given in the question? It is given D is equal to 18 meter, H is equal to 10 meter, H1 is equal to 28 meter, D0 is equal to 8 meter, D1 is equal to 6 meter, and gamma saturated is equal to 20 kilonewton per meter cube. Gamma submerged is equal to 10 kilonewton per meter cube. Phi is equal to 30 degree. Factor of safety is equal to 2. Now considering the light well, let us first find it out what is the value of Ka. Ka is 1 minus sin phi by 1 plus sin phi, which is equal to 0.333. The phi value is given 30 degree, and Kp 1 by Ka, which is equal to 3.0. So, case 1, light well. In light well, what is the formula? 2D1 is equal to 3H1 plus minus root over of 9H1 whole square minus 2D into 3H1 minus D, which is equal to 3 into 28 plus minus root over of 9 into 28 whole square minus 2 into 18, 3 into 28 minus 18, which is equal to 84 plus minus root over of 7056 minus 2376, which is equal to 84 minus 68.41, which is equal to 15.58. So, D1 is equal to 7.79 meter. Then Q maximum, putting the value as derived earlier, Q maximum is equal to half gamma submerged D Kp minus Ka into D minus 2D1, which is equal to half into 10 into 18 into 30 minus 0.3 3.0 minus 0.33 and 18 minus 15.58, which is equal to 580 kilonewton per meter. Total force, so total force Q maximum is equal to 580 into 8, which comes out to be 4640 kilonewton. Then allowable is equal to 4640 divided by your factor of safety is equal to 2.0, which is equal to 2320 kilonewton, which is greater than 1000 kilonewton for light well. Now similarly for heavy wells, case 2, that is the case of your heavy well. In heavy well, Q maximum is equal to, it is your 1/6 gamma submerged into Kp minus Ka into dq by H1, which is equal to 1/6 gamma submerged is equal to 10, 3.0 minus 0.33 and 18 whole cube by 28, which is equal to 925.83 kilonewton per meter, and Q allowable is equal to 925.83 by 2 into 8, which is equal to 3703.32, which is greater than 1000 kilonewton. So, if you look at the example, one is your tilt is about the base, about a point above the base, that is given the hint, that means it is a light well, and tilt is at the base. So, you have to identify the what are the parameters have been given. In this case, D is given 18 meter, it is said that depth to a depth of 18 meter, H is given at a height of 28 meter. So, 18 total H will be 18 plus 10, this is your H is equal to H1 is equal to 28, H1 is equal to D plus H, H is equal to 10 meter, D 0 inside diameter is given, outer diameter is given, gamma saturated is given, from there you can find it out gamma submerged, factor of safety is given 2, phi is equal to given 30 degree. So, once phi is given, then we can find it out Ka and Kp. Then there are two cases, light well case as well as heavy well case. If I come back to here, let us see. For light well case, this is your 2d1 is equal to 3h1 plus minus 9h1 square minus 2d into 3h1 minus d root over, right. Putting this, we can find it out what is the value of d1. Once you get the d1, then putting this value q maximum, we can find it out half gamma submerged d Kp minus Ka d minus 2 d1. Then for heavy well, this is your formula. So, taking into considerations, I draw it first well in inner diameter, outer diameter. For light well case, how this earth pressure distribution diagram. For heavy well case, what is your earth pressure distribution diagram. Then D1 has been calculated. Once D1 has been calculated, Q maximum has been calculated, total force has been calculated, allowable force has been calculated, and it has been checked this allowable force should be greater than your lateral load. Lateral load is your 1000 kilonewton. Similarly, for heavy well, based on the formula Q max has been calculated, Q allowable is your 3703.32, which is greater than your lateral load on the well. Then come to your next problem, next example. Example 2, a circular well of 4-5 meter external diameter and 0.75 meter staining thickness is embedded to a depth of 12 meter in a uniform sand deposit. The angle of shearing resistance of sand, particularly what is given, phi is equal to 30 degree, gamma 1 ton per meter cube. The well is subjected to a resultant horizontal force of subjected to a resultant horizontal force of 50 ton and total moment of 400 ton meter at this cover level. Assuming well to be lightweight, compute the allowable load a factor of safety of 2, factor of safety is equal to 2 has been given. Determine the magnitude and point of maximum bending moment in the well staining. Another question is asked. First one is your compute is your allowable load, second one is your determine the magnitude and the point of maximum bending moment in the well staining. A circular well of 4.5 meter external diameter and 0.75 meter staining thickness is embedded to a depth of 12 meter in a uniform sand deposit. Phi is given 30 degree for the soil, gamma submerged is given 1 ton per meter cube. The well is subjected to a resultant horizontal force of 50 ton. The load is coming 50 ton and the total movement is 400 ton meter at the scour level. Assuming well to be lightweight, compute the allowable load, factor of safety is equal to 2.0. Second one is your determine the magnitude and the point of maximum bending moment in the well staining. Now H is equal to m by q, which is equal to 400 by q is equal to 50, which is equal to 8 meter h. H1 is equal to 20 meter, h plus d is equal to 8 plus 12, which is equal to h1 is equal to h plus d, which is equal to 20 meter. Now you calculate 2d1, 2d1 is equal to 3h1 plus minus root over of 9h1 square minus 2d, 3h1 minus d. Then from there d1 comes out to be 5.26 meter. For phi is equal to 30 degree, Ka is equal to 0.333, Kp is equal to 3.00. So now we can calculate Q maximum, which is equal to d Kp minus Ka into d minus 2d1, which comes out to be 23.68 ton per meter length. Then Q allowable is equal to Q maximum into L divided by your factor of safety, which is equal to 23.68 into 4.5 divided by 2, which is equal to 53.28 ton. So, 53.28 ton is coming, but actually force is coming 50 ton. So, that means it is safe. Now, what has been asked second question? Determine the maximum and the point of determine the magnitude and the point of maximum bending moment of the well straining. Maximum bending moment will occur when the shear force will is equal to 0. If I come back to earlier one I have explained, you see for maximum bending moment shear force is 0 and this is the formula. At what distance your maximum bending moment will be there. If I write it, x is equal to F_q by gamma submerged Kp minus Ka into L root over of half, which is equal to 4.08 meter. Maximum bending moment is equal to q h plus x minus q into x by 3, which is equal to 50 into 8 plus 2 into 50 into 4.08 by 3, which comes out to be 536 ton meter. So, maximum bending moment will be 536 ton meter and it will be at a distance 4.08 meter below the base. Now, one more example I am giving it to you, one more problem I am giving it to you, you can try. This will be not related well, this will be something about one more pile problem I am giving. A precast concrete pile of size 45 centimeter by 45 centimeter is to be driven into stiff clay. The unconfined compressive strength of clay is for clay is equal to 200 kilonewton per meter square. Determine the length of the pile required to carry a safe working load of determine the length of the pile required to carry a safe working load of 400 kilonewton with factor of safety is equal to 2.5. Assume alpha is equal to 0.55. I will stop it here. So, next class I will start more about this well foundation, about sinking of wells, how this performance will be done. Thank you.